Hi everyone, welcome to our video. In this video, we are going to talk about differentiation. But before that, let me introduce myself. My name is Izwan Iskandar and I will be your guide in this lesson. So, let's get started. For the first rule, it is constant rule. If y equals to c, where c is constant, then dy over dx is equals to 0. It means that when any real number are differentiated, it always becomes 0. Look at the examples. The first one, when we differentiate 10, we will get 0. But also the same with others. When we differentiate negative 7, 1 over 2, 25 and negative 35, we will also get 0. Next is rule number 2, which is linear rule. If y equals to cx, where c is constant, then dy over dx is equal to c. It means that when we differentiate linear equations, you will always get the constant back. For examples, when we differentiate 4x, we will get 4. When we differentiate negative 7x, we will get negative 7. And also the same with others. When we differentiate 1 over 2x, 25x and negative 15x, you will get 1 over 2, 25 and negative 15. Now let's look at rule number 3, which is power rule. If y equals to x power of n, then dy over dx is nx power of n minus 1, where n is a real number and cannot be equals to 1. When you get any variables, the variable in the examples used is x and power with any real numbers. You have to multiply the power with the variable first, then you have to subtract the power with 1. For examples, when we differentiate x power of 5, you will get 5x power of 4. When we differentiate x power of negative 3, you will get negative 3x power of negative 4. It also the same when we differentiate x power of 3 over 2, x power of 4 and x power of negative 1 over 2. In respect, we will get 3 over 2x power of 1 over 2, 4x power of 3 and negative 1 over 2x power of negative 3 over 2. Next is rule number 4, which is logarithmic rule. If y equals to ln u, then dy over dx, you will get 1 over u dot du over dx. The general formula explains when the natural logarithmic, which is ln u, for the general formula is differentiated. It will always become 1 over u, and you have to differentiate the u and multiply it with 1 over u. To get more understanding, let's look at the examples. When we differentiate ln x, you will get 1 over x. Then differentiate x, you will get 1 and multiply it with 1 over x. The answer is 1 over x. The second one, when ln 2x, it will become 1 over 2x. Then differentiate 2x, you will get 2 and multiply it with 1 over 2x. The answer is 1 over x. The next rule is rule number 5, which is exponential rule. If y equals to e power of u, the general equation means that it is exponential equation. When we differentiate it, you have to copy back the exponential. Then differentiate u, which is the power, and multiply it with the exponential. For examples, y equals to e power of x, you will get e power of x only, because when you differentiate x, you will get 1 and multiply it with e power of x. Next example is e power of 2x. Copy back the exponential, which is e power of 2x, then differentiate 2x. You will get 2 and multiply it with e power of 2x. The answer is 2e power of 2x. Next one is rule number 6, which is sum rule. The equation has multiple terms, which means that more than one term. And the example in the general formula we use are fs and gx. In differentiation, we have to differentiate it separately. Let's look at the examples. When y equals to x power of 2 plus x, you have to differentiate it separately. X power of 2, you will get 2x, and x you will get 1. So the answer is 2x plus 1. Another one is e power of x plus ln u. You just have to use rules before this to differentiate it separately. E power of x you will get itself, and ln u you will get 1 over u. And the final answer is e power of x plus 1 over u. Next one is rule number 7, which is difference rule. This rule is exactly the same as rule number 6, which is you have to differentiate it separately. But the difference is, instead of addition, we use subtraction in the equation. The examples are also the same as rule number 6. Next rule is rule number 8, which is product rule. When the equation has two terms with variable in multiplication, you cannot differentiate it directly. So, you have to separate the two terms to differentiate, which are fs and gx. After you differentiate fs and gx, it will become f prime s and g prime s. Then, use the product rule formula dy over dx equals to fs g prime s plus gx f prime s to differentiate the whole equation. Look at the example. Differentiate y equals to x squared ln s. Separate x squared as fs and ln s as gx. After you differentiate, f prime s is 2s and g prime s is 1 over s. Use the product rule formula to combine. The final answer is 2s ln s plus x. Next rule is rule number 9, which is quotient rule. We use quotient rule when there is a fraction and the numerator and the denominator have variable. The quotient rule is dy over dx equals to gx f prime s minus fs g prime s over gx squared. The concept is the same as rule number 8, where you have to separate it to differentiate. The numerator must be fx and denominator is gx. Then differentiate both and combine it using the quotient rule formula. For example, y equals to x squared over 2x plus 1. The x squared as fx and 2x plus 1 as gx. Differentiate both sides and combine it in the quotient rule formula. You have to make sure simplify after make it the formula form. And the final answer is dy over dx equals to 2x over 2x plus 1 squared. Lastly, rule number 10, which is general power rule. If y equals to u power of n, where u equals to fs and n equals to constant, then dy over dx is equal to n dot u power of n minus 1 dot du over dx. The general equation means that when a function which is in the bracket and have power outside the bracket, you have to differentiate outside the bracket first. It means that the power outside the bracket is bring to the front of the function and subtract the power with 1. Then, differentiate inside the bracket and multiply it with the function. Simplify it and you will get the answer. The example is y equals to x squared plus 1 power of 3. Differentiate outside the bracket, bring 3 to the front of the function and subtract power with 1. Then differentiate inside bracket, you will get 2x. Multiply 2x with 3x squared plus 1 power of 2. And the final answer is 6x x squared plus 1 squared. Next, partial differentiation. Partial differentiation means that you have to differentiate with respect to x and y separately. For example, when there are two variables which are x and y, then partial differentiation is used. Differentiate with respect to x means that you only have to consider to differentiate x only. Similarly, when it is respect to y, you only have to differentiate y only. Now let's look at the example. When fxy equals to x squared plus y squared, differentiate it with respect to x. Differentiate x squared and you will get 2x as the answer. You ignore y squared because there are no variable x. Then you have to write d over dx fxy equals to 2x, that is the answer. Otherwise, when it is with respect to y, differentiate only y squared. Then you will get 2y is the answer. And that's all for today's video. I hope this video gave you a clearer understanding of this topic. Thanks for watching and goodbye.